we are going to derive some physics formulas. And all our formulas are going to assume constant acceleration. Now, we know that the derivative with respect to t of v is a. And we also know, we know this formula, and we also know that the derivative of the displacement formula is the velocity. Well, that tells me that the integral of a dt is equal to v. And this here tells me that the integral of v dt is simply s. Okay, so we know that v is the integral of a dt, but a is a constant, so you're going to get at plus a constant. Since it's velocity, the constant will be 0. That is, we have that v, I'll write v0 first, is equal to v0, the initial velocity, plus at. That's one formula. And from here, we know that s is equal to the integral of v dt, but we know that v is this. It's v0 plus at dt. Well, since we integrate v0 dt, and since v0 is a constant, we're going to get v0t plus the integral of at dt is 1/2 at squared plus a constant. I'll put the constant in the front. So it's S0. So we now know that the displacement formula is where you start, oops, that should be a plus v0t. The S0 where you start, plus the initial velocity times the time that you're going for, moving for, plus 1/2 at squared. So we can quickly get those two formulas. We will call this the first formula and this the second formula. And from the first formula, from 1, we could say solve for a. We bring this over. We get v minus v0 is equal to at. And then we can either divide by a or t. If we divide by t, then we get what a equals. A is the change in the velocity, final velocity minus initial velocity over the time. Or, if instead of dividing both sides by t, we divide instead by a, then I will have what t equals. T is equal to v minus v0 over a. Basically, you can always interchange those two. You can always interchange the locations of those two. And that's basically what happened here. So we have another formula. And there are ways to get other formulas from, say, 1, 2, and let's call this 3. I'm not going to call this 4 because it's the same as 3. It's exactly the same as 3. in fact, let's not even call that 3 because it's the same as our first equation, the same as the first. Now, for example, you can solve this for v0, and which will be v minus at, and maybe you can plug that in right there. Or, as we did, we solved 1 for a. You can now take this way of writing a and plug it in right there. Say s, which used to be s0 plus v0t plus 1/2 at squared. I haven't done physics in a while, so let's make sure I'm right. Okay, so you can plug this in right here for a, and then you'll get this is s0 plus v0t plus 1/2 times the new way of writing a times t squared. And the new way of writing a is v minus v0 over t. And we can simplify the t's. 1t here for 1t here. So we get v minus v0 times t. Distributing out that t, we get 1/2. Well, the t is like here, so let's distribute the whole thing. We get 1/2 tv or vt minus 1/2 v0t. And then I say, oh, if you have 1 v0t and you take away a half, you must be left with the other half. So that's another formula, and we could simplify this one a little bit by factoring out the 1/2 t. So I factored out this in the first term, and this and that in the second term. So literally what isn't in purple, we write down. Namely, we write down the v0, we write down the plus sign, and we write down the v. And I'll just change the way I write this. It's s0 plus v0 plus v over t, over 2, which over the 2, which meant I dealt with this and the half. And then all of this gets multiplied by the t. I wrote it this way because that's the average speed times t. And we should really make sure that, I just want to see one thing. This should be s, which is the distance, say meters. So let's see. This here will be in meters, plus velocity is going to be meters distance over time, maybe, meters over seconds, and you multiply by seconds, so you're left with meter plus meter, which is some number of meters. That is the units checked out. And we can solve this equation for t. Bring this over, so you have the change in s is equal to this quantity times t. So s minus s0 times the reciprocal of this times 2 over v plus v0 plus v will equal the time. So if you have the final displacement initial replacement, initial and final velocity, and you know what the number 2 means, you got t. That completes this